Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. This particular lesson is going to be focused on complex numbers. What are they and when do we use them? If you go ahead and you're trying to solve x squared plus 4 equals 0, and if you look at it graphically, you're going to notice it never crosses the x-axis, but maybe you need something from this for some reason. Maybe you're doing some theoretical physics work or something to that effect. There's no real x-intercepts. If you look at the quadratic formula, the discriminant, 0 squared minus 4 times 1 is going to be -4. So it's less than 0, which further supports the fact that there are no real roots, emphasis on the word real. So what mathematicians have done is they've said, okay, well, x squared is going to be -4. So x is going to equal plus or minus the square root of -4, and I can't do that. However, I know 4 is 4 times -1, right? So this is plus or minus 2, and instead of writing the square root of -1, I'm going to abbreviate that I. That's all they've done. And that's what a complex number is. It's a number that has an imaginary part. So a plus bi is going to be complex form. A will be your real part, and b will be your imaginary part. Now notice I didn't say bi. So if you're utilizing the program in my classroom and the online program asks you for the real part and the imaginary part, they don't want you to type I. They just want you to type the A value and the B value. Now, could A or B be 0? Yes. And if B is 0, then isn't that a real number only? Absolutely. So if I have 3 minus 2i, the real part is 3, and the imaginary part is -2. If I just have 5i, isn't this the same as having the real part being 0 and the imaginary part being 5? Yes, because this is the same thing as saying 0 plus 5i. Does that mean I can write any real number in complex form? Yeah. 9 plus 0i. I mean, I get that it's 9. But again, that's what my textbook that I know I utilize in my classroom, and has an online program. And the online program gets very picky about how you write it. So the good news about I is 90% of the time we're going to work with it like it is a variable. There's just a couple catches. Simplified form. Must be written A plus bi. Now, I must be a multiplier. I cannot be in the denominator. I cannot have an exponent. It has to be written A plus bi. Now, how are you going to get rid of exponents? Well, remember how I is equal to the square root of -1? That means I squared is equal to just -1. So make sure that you take care of that step anytime you happen to see an exponent. So let's just try some math. Three minus 9i plus 2 plus 5i. Treat it like a variable. If it were a variable, what would you do? You would combine like terms. We're going to combine like terms. The 3 and the 2 are both the real parts, so we're going to combine the real parts to get 5. And then we're going to combine our imaginary parts. -9 plus 5 is -4. It's written in A plus bi form. We're done. So what if I had 3 minus 2i minus 7 plus 3i? Well, still going to work with it just like this were variables. So we're going to combine our like terms. 3 minus 7, but we'll have to distribute the negative first, right? So 3 minus 7 is negative 4. Negative 2i minus 3i is minus 5i. Okay, not bad, right? What if I had 5 plus 2i multiplied by, 3 plus 7i? Okay, well, we're going to treat it like it's a variable. If it were a variable, we would just FOIL it out. So that's what we're going to do. 5 times 3 is 15. Let me make my arrow better. 5 times 7i is 35i. 2i times 3 is 6i. And 2i times 7i is 14i squared. So that would give us 15 plus 41i plus 14i squared. But this is not written in a plus bi form because of this right here. So I have to remember that I is equal to the square root of negative 1. So I squared is going to be the square root of negative 1 squared, which is just negative 1. Hallelujah, I can do that. 15 plus 41i plus 14 times negative 1. Oh, well that's just negative 14. And when I add 15 to it, I get 1. There we go. That wasn't so bad. What if I had a power bigger than 2, though? Okay. What if this were I to the 25th power? Okay. Well, I squared, I know, and I know, right? But I need 25, and I'd like to not have an exponent on this. Would you agree that that's the same thing? Because 2 times 12 plus 1 is 25, right? So we would have negative 1 to the 12th power times I, and anything to an even power is positive, so that would give us 1 times I, which is I. So I to the 25th equals I. If you cannot do that, if you cannot use your exponent rules, here is your fail-safe. Okay. I1, negatives on the middle, right? Okay, hope the number's not too big. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That's our answer. Well, let's try that again. Let's do I to the 10th. Well, that's I squared 5 times, which is negative 1 to the 5th, which is negative 1. Or you could go, watch the pin carefully, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1. So again, if you're doing the counting thing, it's I1, negatives in the middle. So any power of I can be reduced. Okay, so we've added I, we've subtracted I, we've multiplied by I, we have not divided by I. Okay, you're not actually going to divide these. But we still need them written in a plus bi form, so we can't have I in the denominator. So we're going to get I out of the denominator the same ways we got radicals out of the denominators, and that's by multiplying the numerator and denominator by the conjugate. we're going to use that fact that a squared minus b squared pattern is equal to a plus b times a minus b. It really helps us in these cases. So we're going to multiply by 1, technically, because multiplying by 1 doesn't change anything. I just happened to choose the fact that my numerator and denominator for 1 was going to be 5 plus 2i. Why 5 plus 2i? Because it's the conjugate of 5 minus 2i. And we're just going to FOIL. 35 plus 14i plus 15i plus 6i squared. 25 plus 10i minus 10i minus 4i squared. Okay, combine like terms. 35 plus 29 plus 6i squared. I'm just going to go ahead and write -1 over 25. The 10i and the minus 10i will cancel, and I'll have minus 4 times, just going to write -1. So now, I forgot my I. Oops, there we go. When I take the 35 and I add 6 times -1, I get 29 plus 29i. When I do the denominator, I get 25 minus 4 times -1, which is going to give me 29. Oh, hey, this reduces nicely. Will they all reduce this nicely? No. This became 1 plus I. If you ever wind up with something like -7 plus 2i over 5, that's technically not an a plus bi form. You would write it as 7/5 plus 2/5 I. Now it's written in a plus bi form. Okay. Also, what happens if you don't have an a value in your denominator? For example, 7 minus 9i over 3i. Well, technically, you do have an a value at 0 plus 3i. So you would multiply by 0 minus 3i. Whatever you do the bottom, you do the top. Is it necessarily to have the 0 and do FOIL? No, you can treat it as a distributor. Okay, so when we multiply this together, that'll give us -21i plus 27i squared over -9i squared. Remember, I squared is -1. So this is really -21i minus 27 over 9. And if I put it in a plus bi form, I'd have to put the part without the I first. Then reduce those respectively. These both divide by 3. So you should be able to add, subtract, and as well as multiply and divide imaginary roots. Now I will tell you that if you're working with these, the first thing you're going to do is you're going to pull out that I. So this is the same as root 16i, so 4i. So if you have a problem like this, the first thing you should do is you have to make them real numbers before you can work with them. So you can't dump them into the same basket until they're real numbers. So we have root 2 times I multiplied by root 3 times I. Now we can multiply them together. We can multiply the square root of 2 and the square root of 3 and get the square root of 6. I times I is I squared, which is -1. So we'd have negative square root of 6. So make sure that you are doing the proper order of operations with these. And then if you're solving and doing the quadratic formula, make sure that you understand that imaginary roots happen. It's not a big deal. But from here on out, your teacher's probably going to expect you to give answers in a plus bi form. Okay. Now, if you're dealing with a quadratic like x squared plus 4x plus 5. These are real coefficients. If a plus bi is a root, then a minus bi is also a root. And it has to do with that plus or minus being part of the quadratic formula. So let's check that out. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So it gives us negative 4 plus or minus 16 minus 20 is negative 4. Okay, so we'd have negative 4 plus or minus 2i. Oh, negative 2 plus or minus I. See, negative 2 plus I and negative 2 minus I. Both of those were answers. Because, again, with nice coefficients like that, you're going to get both of them. The only way that you wouldn't get both of them is if we were giving you imaginary coefficients. And I don't know that you're at that point in your mathematical career where you're getting imaginary coefficients. So, keep in mind, the i's are mostly treated like variables. You just cannot have them in the denominator, and you cannot have them with an exponent.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.